Don't you just want another video about CQRS, mediator, event sourcing? Some kinda clean, hexagonal, whatever architecture? No, you don't. You want something of substance. You want something that is going to make you a better programmer. And that's what I'm bringing you today. A programming paradigm that you probably never heard about because nobody is talking about it except for a small niche of people. My name is Anton. Welcome to the Raw Coding YouTube channel. I worked quite a bit to make this video, so make sure if you're enjoying it, like and subscribe. Now let's go. The programming paradigm we're covering today is called Data Context Interaction, DCI for short. Before we get into the meat of DCI, let's talk a little bit about the history or context of DCI, who came up with the idea, who's pushing it, etc. Who are the people behind it, right? The people are important. I don't know the exact creator, but the two main people that are pushing DCI and are trying to let other people know about it. The first person is Trygve, the creator of the MVC framework that you probably know, used, and every single other developer out there. And the second one is James Kaplan. Now, James Kaplan has done tons and tons of work and has pioneered many different things in the programming sphere, from writing books to development methodologies, and obviously solved very hard problems in his time.
I worked for AT&T for 20 years. We made pretty complex, reliable systems. These things could be down for, well, regulatory requirements were 30 seconds a year for all reasons, and actual practice was 5 seconds a year. That includes software updates. These were large, complex distributed systems serving 100,000 telephone customers. They had to be able to recover from double-bit undetectable memory parity errors that were caused by alpha particles. I mean, this is a hard problem. And trust me, we didn't get there by testing. You got there with good design and being able to understand the code.
I'm speculating here, but cumulatively, both of them are probably holding around 90 years of programming experience together. So why would you not actually try to listen to them and see what they're saying about data context interaction and what the hell it is? So let's come to the drawing board and see. Now, if I tell you to create some kind of system, the first things that you are going to try to think in terms of is a database. You're going to have some kind of database. You're going to have a server, which is going to be your API, where you're going to say, I'm going to have some endpoints and I'm going to have some models, and these models are going to go into the database. And then you're going to start thinking about your data access layer. What repository do I want, right? All the stuff that probably doesn't matter in the eyes of DCI. DCI as a programming paradigm is trying to shift your focus. It's trying to take your focus away from all of those components that you're trying to arrange together to produce your system that are only contained within your head as a programmer. A user doesn't know what an API is or a database, etc. They may know, yeah, that's where the data is stored, but whatever, but they don't know what's actually going on under the hood. The point of DCI is taking that focus and shifting it towards developers thinking about what the users are thinking. Nothing to do with classes, nothing to do with interfaces, nothing to do with infrastructure. It is purely about ideas, thoughts, and how a person is laying out the process in their own head. That idea that the user is thinking about of something that should happen, that is essentially the use case. That is what your application is doing, and as James is arguing,
No, I mean, the revenue and the business focus is on the use case. That's what we sell. We sell use cases. We sell functionality. We don't sell classes. But yet our code, if you're programming in Java, does not allow us to reason about the number one thing that we sell, and we cannot find it in our code. If you have some feature you're selling to your customer and I say, can you go please draw a circle around this in your code? You can't. So how in the hell can you know it works?
That is what we sell. We don't sell classes, we don't sell databases, we don't sell design patterns. That's the premise of it. We as developers develop use cases and we sell use cases.
Bunch of nerds.
With that said, what are the building blocks in DCI? If we cannot use classes, etc., what do we use? It's how we think about things, and generally humans will think about things in stories. And a good example for this is if you ever go into a theater, you're going to have a stage, and on that stage, you're gonna have some props. So let's say that this is a makeshift castle, and then Juliet is standing over here, nice pretty hair. We're not gonna draw the rest. And then you have Romeo over here. The actors have assumed their roles, and then we play the scenario, and we see this scenario being enacted by the actors in these roles. Romeo will say something to Juliet, Juliet will say something to Romeo. At some point, the scenario is going to finish, and the scenario is going to be erased. As human beings, that was a very natural way of understanding an idea, a story. That's how we understand things. We literally tell stories to each other. And that is what data context interaction is about. You have a box, some kind of context. This would be your story, your scenario. And in this scenario, you're going to have roles. So how we had Romeo and how we had Juliet, these are both roles. And I'm going to denote them by these R's. And what they're doing is they're interacting. This is the I of DCI. The things that are happening between roles, which are played by objects, and then you have data. You have some kind of objects in memory that get placed into these roles. So you would have more data over here and it would get placed into here. And then just like you would have the castle in the story as a bit of a prop, you can also have helper classes or props within that context that are helping to keep the context together, okay? So this is all abstractly speaking, going from human-told stories to how we try to represent stories using DCI. And now let's actually try to tell a story. And by the way, one thing I didn't mention yet, context represent use cases. An initiation example into DCI is the money transfer example, where you have an account, so let's say an account and another account, and you want to send money from one account into another. So this is an actual implementable example. However, if we try to squeeze it in a little bit more into DCI, here is going to be our context, which generally in the examples is called the money transfer context, the context of transferring money. What roles are there in this context? The first role is the source account, where the money is being transferred from. Where is it being transferred to? It's being transferred into a destination account. You can then have a database somewhere on the side where you're gonna have two records, two accounts, and one account is going to be plugged into the source. The second account is going to be plugged into the destination. And please note, I am saying plugged in. The dumb data that comes along to play a role doesn't have any functionality that comes along with it. The only time a class starts having functionality is when it's playing a role. And when it's playing a role, it has interactions for its functionality that it has with other roles that are in this same context. So the source account is trying to send some kind of money to the destination account. Now there is a prop here that we cannot see, which is essentially the bank. We're gonna get rid of this arrow here, and I know I'm a great artist. Look at this bank I just draw. Ridiculous. If I wasn't a software developer, I'd be a Picasso. But anyway, the bank withdraws money from the source account, and then the bank deposits money into the destination account. And that is pretty much it. Look at how simple it is to represent this idea on paper. The big problem that is coming along is these concepts. That we have a concept of role, we have a concept of context, we have a concept of interactions. These concepts do not translate too well into the current object-oriented programming languages as they're known. According to James, all of the languages that we use to program are class-oriented, except for JavaScript, a real object-oriented programming language. What we are actually doing is we are class-oriented. When we are creating our applications, we're thinking about class hierarchies, how to wire up the services, etc. And for that reason, I think it's true. We do not program in objects. We do not program with the things in memory. Basically, all in all, our programming languages don't have the facilities to work with context and roles and essentially in a DCI manner. The same way that a functional program would be able to pipe method calls from function 1 to function 2 to function 3, so the result of the function is just fed it to the next function. We don't have that in C#, but if you are programming in F#, that is something that's possible. The same way we don't have functional programming support, the same way we don't have DCI programming support. Now enough of all the drawing, we're not little children, we're programmers, let's write some code. We're not going to be doing a money transfer example, we're going to be picking a product from a shelf into our cart or vice versa. You know, you're going to pick a product up, you're going to put it somewhere else, similar to the money transfer example, but not quite the same. Let's say we're going to have a product class and it's going to look something like this. We're then going to create our context. This is going to be a pick product. And from experience, one thing that I noticed about DCI is you no longer have classes that sound like product manager, X manager, provider, doer. You don't have those types of classes. You have well-defined use cases that happen. When we're picking a product, we are going to have two collections of products. One collection is essentially the shelf where I'm picking the product from, and the other collection is my cart where I'm placing the product. Instead of pick product, this can also be called add to cart. And in the constructor, we're going to supply a list of products. And there we have it, shelf and cart. The first product collection, the shelf, is going to play the role of a shelf. And the role of the shelf is going to be able to take a product from here. We're going to have a take function. All this is going to do is grab the first product on the shelf, return that product, and make sure we remove this product from the shelf as well. And then we have the cart role, which is going to be placing a product into the collection. So cart, add product, semicolon on the end, semicolon over here. We're going to take shelf, plug shelf into the shelf role, and then we're going to take cart, plug cart into the cart role. And then we're going to have a function, which is essentially a main function. This can be run, execute, whatever makes the most sense. It's essentially a scenario, a use case that you're performing. We want to go to the shelf, we want to take a product, we're going to have this product, and then we want to go to the cart and we want to place this product into the cart. Let's create our product lists. We have the two lists. Now we create the context. We then execute the context. And then we print out all the products to the console. Cool. Let's go ahead and compile our application. After a little bit of struggle, I managed to compile it, and let's go ahead and run it. There is the result. Nothing spectacular. We moved the product from the shelf into the cart. Now, probably some of you went, "Roll, what the hell is this?" And this is a programming language called Marvin, which is basically built on top of C#. Everything in here is C#, just the addition of roll to be able to build context to support DCI. You can see here there is a little bit of a dynamic thing going on where we take shelf and we just bind it to shelf. I have to do a little bit of casting here so it actually understands what kind of remove function I want to call, but this is because the language is experimental. All it's trying to do is be a proof of concept for having building blocks for creating contexts, building blocks for creating roles, and then having interactions between these roles. So you play, there's a shelf, you pick an item from the shelf, and then you place the product into the cart. Now, there is not a lot of interaction happening between the shelf and the cart, and I will show you a little bit more on the interaction side in just a bit. This was mainly to get you familiar to what it would look like in Marvin. Now, if we take this example and we take it over to the C# world and we place it over here, we're obviously not gonna have any of the roles, etc. What would it actually take us to do the same thing but currently in C#? So first of all, we don't have roles. Let's go ahead and just change them to classes for now. We'll take class cart. I'm gonna format the code so it's actually readable. I could have a constructor over here where I'm injecting the shelf into the shelf role. However, that's not what I'm gonna do. What I will opt in for is instead using the record, because this is basically just going to remove a lot of the boilerplate code for me. So I'm going to have a list of products on the shelf, and once I'm picking the item, I'm also removing it from the shelf, and then I'm also going to return a product from over here. Let's take the play function, and I'm actually going to move it to the top over here. We're going to make sure that we have the properties for the shelf. So shelf is going to be a shelf. And here there is a name collision, which we didn't have when we were doing it in Marvin. So let's name this role shelf role. Shelf is going to be playing a new shelf role to which we put in the shelf products. And then we will have to do the same for the cart. Here's a cart role extending a list of products to be able to allow placing into that list of products. We will now define a property for it and integrate the list of products into this role. Finally, there are a bunch of errors with access modifiers, so let's just resolve that. With all of that, the code compiles. Let's go ahead and run it. So .NET run, and we should be able to just get the same result. So a pretty simple example. Now I want to take it into the ASP.NET Core world, and we're going to be modeling TikTakToe. We're going to come back to the drawing board. And by the way, we didn't do the money transfer example because if you look up DCI, this is all you see. So that is the reason why we're not doing it. But let's go ahead and clean this up. So for the game of tic-tac-toe, what do we have? We have the board, we then have player 1, we then have player 2, and these players will take turns to try to place symbols into the board, and at some point it is going to finish. It's very interesting. When I initially tried to build the application this way, it was very challenging, very similar to how you feel trying TDD. But once I got going, it actually makes a lot of sense. You have an object over here, you have an object over here, and then you have an object over here. These objects are going to be communicating with each other, so they will be able to take turns. There is also an additional context of essentially the game. This is the prop, kind of like we had the bank for the money transfer context, where the player is going to think, is it my turn to go, kind of thing. And if it's your turn to go, you're actually going to take your go. And one challenging thing that I've seen over here, what the hell is that? And one of the challenges I found with this model is that essentially you have this is my parody on Google Chrome, right? You have two browsers that are open in the server world, and then you have your backend where you have the information, right? If I take this model and I lay it over this, if we take the same analogy for the money transfer or the add product to cart, we're forcing an enactment. We cannot force players to sit in front of their computer and start putting in commands, right? That's impossible. So this is rather becomes a definition, a context for where these objects are interacting. So when we have these objects in this context, what is actually going to happen is there is going to be this context of the game, and I'm just going to draw it as this bar over here, which is going to make sure that we're staying within the rules of first player takes a turn, next player takes a turn, next player takes a turn. And when this player tries to take a turn, there is going to be an event, a message that pops up, and we're able to essentially proxy this event over here. And while this side over here is raising events, nothing is really stopping this side from raising events as well. So there is an event over here. So there is going to be messages sent constantly back and forth between these components. And this is partly what Alan Kay's vision, I guess, is, where you have an object over here, an object over here, an object over here, and you send a message here, you send a message here, this object sends a message here. All DCI is doing is it's saying, look, this pattern for sending messages within objects, this is a use case, this is a context, they are sending certain messages, they're interacting between each other in a certain manner, and this is a thing that we can sell. If you've ever done distributed computing, this is essentially what this is. Each individual node can be considered as an individual computer. What you're doing when you're defining a context, you're indeed providing a script for interaction between distributed components. With tic-tac-toe, it is going to be quite simple, but hopefully if you are doing distributed computing, you can see how powerful this is. Another thing that it actually reminds me of is Unreal Engine blueprints. I think some people may know this concept as workflows, but again, it doesn't sit next to the idea that we have a use case, and this use case, as it is in a human's brain, we don't have the tools in our programming languages to actually be able to describe it. However, let's go ahead and see if we just try to program in a DCI way. I'll create my context, tic-tac-toe game. I'll create a constructor into which what I'm going to do is I will seed a game. So class game seed, and this is going to have an identifier for the game. So let's say good ID. The game seed will also hold host and guest, because there is a little bit of a setup process before we actually get into the game. Let's go ahead and supply the game seed into the constructor. Let's come back to the board and take a look at the roles that we have. As I said, there are essentially 3 or 4 roles, which is the board and the 2 players. Let's create these roles. The first one is going to be the board, so public class board, and let me make a little bit more space at the bottom here. As we've learned before, it is better if the roles are records, and the board specifically is going to be a character array that is going to contain slots. And then the interaction that can happen between a user and a tic-tac-toe board is a user. If you take a look at the actual real world interaction, you mark a square, okay? So we got our domain specific language going on over here. Public void mark. We want to mark at some kind of position, and we want to place some kind of symbol. This is just going to go to the slots, at position, place the symbol. Now let's add another role for the player. The main thing that the player is going to be doing is he's going to be trying to use these take turn events. That's all a player can really do, is try to take a turn. And when the player takes a turn, he has to provide a position of where he wants to place the actual mark. Here, 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 or here. So we're really listening for messages of taking turns within the player. And what I really want you to realize here is that the way we have this diagram over here, this context only exists on the server over here. The users at these points are kind of virtual. What the browser is going to do is it's going to make a request, and then the user is going to try to take a turn. So when we define an endpoint take a turn, we want to be able to reach into one of the players in the tic-tac-toe game and try to force him to take a turn. So public, this will be a task for now, and we'll call this take turn. We want to force the player to take a turn at a position. So this is going to be the position, and the player itself will contain the information of what kind of symbol the player is playing as. So char, symbol. The player will then need to be able to reach the board and try to mark the board with the symbol. One thing that you haven't seen in Marvin is if you have this function scope, it can actually reach the scope of the whole class and reach the board. So if we have a board property on the class, it would be able to reach it. In C#, however, this isn't possible. So what we have to do is we have to take the context and we have to pass it into the individual player. Let's go ahead and define the properties for our roles. So board, let's say this is board role, put it over here. This is going to be the board. We'll then create a new board. There's the board with the 9 slots. Now let's add the players. Players will be a dictionary and they will sit under their respective IDs. So from seed host, we're gonna have a new player. The player will have a symbol and we'll pass this as the context. We then add the guest, and now the player will be able to reach the board through the context and try to mark at a position with the symbol of its choice. For now, let's go ahead and return task completed. We'll then add another function, which is also going to be a task, public task play. We're actually kicking off the game. And kicking off the game looks something like this. We're gonna have a do while function. As long as the board doesn't have a winner, so that's another function that we can have here, public bool has winner, and the functions for determining a winner, so on and so forth. I'm not going to spend the time writing out the code. This is more about how to actually write these contexts, not how to write tic-tac-toe. While the board doesn't have a winner, we want to take a player who is going to be the lead, the current player who is meant to be taking the turn. This player is going to be the lead. First of all, pick the lead out of players, so values and then first. And then on the lead, we're going to wait for him to take the turn. This function, the marking function, is going to be the action made by the browser. The game context, this thing over here, the little bar with the arrows, this is kind of meant to sit there and, monitor this player, which is just a proxy for the browser. Let's add another component to the context, semaphore slim. We'll call this finish turn. This will be a new semaphore slim, and it is going to start at 0. We'll go to finish turn, we will wait async, and wait async is not very DCI or DDD type of language, but nevertheless, that is what we're going to be using. Understand that you can mask these methods behind methods of your own choosing, and you can have a method like wait for player to finish a turn. Once the lead has finished taking his turn, we want to set the next player. So lead will equal to players values first, who doesn't equal the current lead. And that should just pick us the other player, and that's how they're gonna go in turns. You can see that this is going to be happening asynchronously to how the player is going to be taking turns. Now, with all asynchronous things, we will need to be handling race conditions. And since the request that is going to be executing this take turn is going to be an HTTP request, we actually want to kind of signal the response. Has the marking of the board been successful? If the board is marked, let's say that we have placed the symbol. I'll convert the function to async. Before we can mark the board, we need to verify that the position is correct. So we will add a verify position function that if the position is correct, we will just return an empty string. And if the string is empty, we will execute this logic. Otherwise, we will return whatever validation message we got here. There's the verification with the board. If the position is less than 0 or more than 9, it's an invalid position. If the character in the current slot is in default, the position is taken. Now, to avoid an off by 1 error over here, because we're looking for numbers between 1 and 9, we're gonna -1 over here. Currently, with the take turn function, both of the players can take turns at the same time. So let's make sure that the context, a lead, is the same object that is trying to take the turn. If not, we will return a message, not your turn, exclamation mark, we're angry. Now, to handle the race condition that can occur here, the reason we have this asynchronous, if I send 2 requests at the same time into 2 different positions, I don't want to be able to mark it in both of those positions. So let's make sure that the player has some kind of flag to represent that it's busy. From the beginning, we're not going to be busy. And if I can't acquire the busy flag, then the process is busy. By the end of the function, we will just wrap this in try finally and make sure we release the semaphore. The last important thing that is missing over here is we want to tell the context that we have actually finished the turn. So if we release the finish turn, we might not be ready to reach the lead until we release the busy, and then another call might come in, so we might get a race condition this way. We are not going to release this way, we will rather create a function on the context, and this is going to be finish current turn. We will move the rotation and the release of the finish turn into here. Let's scroll down here, back to the context, finish current turn, and that looks good to me. So not too much code. I would say quite verbose. If there wasn't all this malarkey going on with having to create these properties and then passing the context around, there will definitely be a lot less lines. Now let's go ahead and hook it up to our endpoints over here. I'll add 2 services for the game seeds and TikTakToe games. Added 2 services, added the ID for the GUID. This is the create endpoint. We get the user ID and just add a game seed to the list of game seeds. We will then want a join endpoint. For the join function, we supply the sessions where after we join the game seed, straight away we create a session and we kick off the task to play. Finally, we need our take turn function. Finally, that's the take turn function. We have the ID of the game, the position that we want to supply. We get the user ID. So for whatever session that we're in, let's try to grab the player from that dictionary and take the turn for that player. Let's run this and see how it fares. And I've realized we don't output the game seed anywhere. So let's create a root endpoint where we can just see the list of games that we have currently. Here I added 2 endpoints so we can peek the seeds for the ID and then we can actually peek the board. Let's run the application. First, let's make sure we log in, and on the other side as well. We will then go over here and create. Looks like that's succeeded. Come back over here. Here is the identifier for the game. So we want to go over here and join this game. We come back over here. Here is the current running game, and if we take the identifier, we can try take a look at the board, and currently the board is empty. So those are the middle slots. Not the prettiest display, but let's check it out. So this is the host, and it should be his first go. So if we try to take turn here, take turn, and first, it should not be our turn. If we take this route, go over here and take turn on, for example, 0, this is going to be an invalid position. If we take it on turn 1, we are going to place X, and X is going to be placed over here. If we then try to place it again, it is not our turn, no matter which position we place it in. If we then go on the other side and we place at position 2, let's go ahead and check it out. There is the thing at position 2. If we then go and let's say try to place at position 1, this position is taken. If we try to place at position 2, this is a bug and shouldn't happen. This is probably an off by 1 error here. Yeah, so the 1 was invalid position, or sorry, the position was taken. This is a position taken as well. A bug found in testing. I'm not going to restart and try to replay the game. This is going to be it for this video. Please tell me in the comments what you think about this programming paradigm, DCI, a way to design your code the same way your users think about the application. Your code reflecting the operational model of the user. I highly encourage you to dive into this rabbit hole of DCI. James Kaplan has a lot to teach, and you will no doubt learn a lot. However, this will be it. Thank you very much for watching. Don't forget to leave a like, subscribe. If you have any questions, leave them in the comment section. You can also use the comment section to say thank you. But better yet, come support me on my Patreon. Get the source code, and very big thank you to all of my current Patreon supporters. Your help is very much appreciated. Thank you for watching. Have a good day.